I haven't really looked into it. Some updates to that plugin could already be available that resolve those issues. But again, the major important ones of at least clean install does work just fine. However, I guess for Gradle users, I'm not a Gradle user. I have heard that it is having some issues right now with Java 9. I know they're working on it. I have a link at the end of this presentation to a presentation by Trisha G, in which it kind of goes into that you got to work using like a lot of command line flags and doing some work. So like it sort of works, it's not totally there yet though. A second major misconception, if you've heard about Jigsaw at all, is like everybody thinks they'll have to modularize their code when they go to Java 9, and again, no, that's not the case. And in fact, it's generally do a serious ROI calculations before you attempt to do modularization. It is a very extensive, labor-intensive process for at least existing code, particularly if you're talking like a monolithic application. So you want to kind of look into if modularization will help you before you attempt it. And I'll kind of get more into modularization here in a couple of minutes. Finally, another major misconception is my libraries for my application will not work. Well, I'll give this one some partial credit. So most libraries actually work just fine. However, libraries that heavily depend upon reflection, like Hibernate, AspectJ, Lombok, I have noticed some issues with. A lot of them, the developers of these libraries are working on updating them. And also luckily, by the time Java 9's released, and by the time many of us will probably get to migrating towards it, there should be pretty stable Java 9 releases for a lot of these libraries. So it shouldn't be much of an issue. It's not so bad right now, and it's definitely going to get a lot better post-release. So all this to say is prove it. Prove that we can actually just migrate to Java 9 without too much of an issue. And since you asked, or I asked myself, I will just do that. All right, so my company, we do some presentations on microservices, and I decided to take our microservice application and see if I can run it in Java 9 without having to make too many changes to it. All right, so the first thing we, of course, have to do is, can we actually build this code? So I just have a script that will go through and build all these applications. And this will take a moment. So these are Spring Boot applications that are also using a lot of like Netflix, OSS to handle like the service orchestration and service registration, Eureka, Zool, so on. And it's also using Hibernate. With the business logic these applications are doing, it's quite simple. I mean, I'm not going to suggest that it's complex by any means. But they are actually relatively, we are pulling in a significant number of libraries, so it's not as though I'm just taking a Hello World Java 8 application that's written with no other additional libraries and then converting to Java 8. These are relatively real-world scenario, realistic applications. So, as we saw, all those applications started up are built without issue and even ran their tests without issue. So now let's see if we can actually run them. And the dialogues for those aren't too important. I may expand one a little bit later. So again, one of the major goals is just taking these, also these applications was not like using all the latest and greatest. This is like a present code from like about 6, or I guess maybe about a year ago. It's running Spring Boot 1.3 and then Spring Core 4.2. I think it's Hibernate 4x. Actually, ironically, Hibernate 4x seems to have less issues with migrating into Java 9 than Hibernate 5x does, because it seems like Hibernate 5x has more of a check for what Java code version you're on, so that's a bit ironic. But anyways, still, I just wanted to, have an application that's not using all the latest and greatest, that's maybe a bit more of a realistic to what people may be working on right now with their systems, because typically we're not always on the most recent versions of libraries. All right. I will give this a couple more moments, starting up about 6 or 7 microservices, so it takes about a minute before everything's fully loaded and ready. I will go and say, though, that at least one thing I ran into, though, is Aspect J, as I mentioned. So the current release is 1.8x, or 1.8x, yeah. And it is not compatible with Java 9, so I am using a beta release of 1.9, and that resolves my issues. Looked like it was happening because of like Hystrix, which is being used underlying a lot of these libraries. So like I said, you may have to update some libraries, but that's actually the only library I did have to update to get this to work. Another one that's having a lot of issues right now is Lombok. I wasn't strictly using it, I just took that out. So that may be one of the more difficult ones that you may have to wait a little bit longer on. From what I've read, the Lombok developers are very confident it will work with Java 9 in the end. It just may take a little bit, and I do know they have some beta releases for it as well. Fantastic, so it works. And again, this is not a complex application, it's just a bit of a workforce project management tool. But let's just go on ahead and just add a new project to kind of show that this is actually doing something. And we'll just simply call it Spring Days Chicago. Give it a description of hello Spring Days, and then finally just 2,000 hours. And there we go. So we have an application that was relatively easily converted to Java 9. Probably one of the biggest issues I ran into is just can I have to familiarize yourself with command line flags, particularly the add modules flag, as you'll need to add some modules in to your module path when you run in Java 9. Another thing that's actually luckily gotten easier with some changes is, did it remove? Well. So as I mentioned, for example, Zool is making use of some stuff in the Java XML module. So I had to add that module to as a command line flag. And then one change made a couple months ago is, so Jigsaw is a lot about encapsulation. And initially, you were having to add a lot more command line flags to open up all these different modules you might be referencing. And then about 2 months ago, they added this kill switch that just turns off a lot of the encapsulation from Jigsaw. And now that's actually going to be a default setting when Java 9 is released, so you won't even need to have that kill switch in there as well. All right, so it's not too bad migrating to Java 9. It's not going to be trivial, but it's doable, and you won't have to completely change your application. So why would we do this, though? Well, this is an upgrade with benefits. Just for running your application in Java 9 and doing absolutely nothing else, you will get better use of memory, better performance, better use of hardware, better documentation, prettier graphics, and faster compilation. So you don't have to do any modularity. You don't have to start using any new of the features. You will just get this just running in Java 9. So there is benefit in just doing that and then not trying to do anything else with Java 9. All right, so on to the big change coming in Java 9 and also the source of much controversy, Jigsaw. Jigsaw is the umbrella name for both the introduction of modularity to the Java language, as well as the modularization of the JDK itself, which I kind of referenced a little bit before. So alone, presentations like this on Jigsaw could last or could be an entire presentation. At the link of this presentation, I give a link to a fantastic presentation by a couple of people from Devox back in Belgium in November, and that lasted for 2 hours. So I'm going to spend maybe about 10 or so minutes here. And if you kind of feel a little bit lost at the end of this, I kind of apologize, but I think it's important to at least get a general idea of what Jigsaw is, even if we can't go entirely in depth into it. So there's 3 major goals and benefits that come from the Jigsaw project. The first is stronger encapsulation. So like right now, public is entirely public. You may have an implementation of an interface that may be public, but you really don't want any client code referencing directly that interface. You are the implementation. You want it referencing the interface, but there's no real way to say use the interface only, don't use this, the implementation other than heuristics of telling developers to do that. Jigsaw provides ways of you will only be able to, you can export exactly what packages you want dictate. So that way client modules then cannot actually have access then to other portions of the code that you do not want them to. Also, this is a way of preventing deep reflective access to, again, get around potential client code from accessing your internal API, and then you are no longer, or you have much more constrained in how you change it. This isn't as relevant to application developers, which I'm guessing the vast majority of us here are, but for library developers, like a few of us here are from Pivotal, this will actually have benefits that if nobody's like accessing an internal API or internal member of like some class that is never meant to be public, people, library developers can have more confidence in changing it without potentially having any unusual breaks. All right, so the second one is more reliable configuration. How many of us have ran into the issue of a class not found when you get to runtime? And it's like running for like 2 hours and all of a sudden you get a class not found, maybe in like an exception. Yeah, exactly. It's very frustrating. You just rely on class path and it's just not that good. It's just, you put a bunch of junk on there and you may have duplicate classes or duplicate versions. Jigsaw is trying to resolve that by adding ability for each module to dictate or declare what exactly modules they depend upon. And this is both a compile time and runtime enforcement. So you will know if you're just trying to build your application whether or not you may be missing a class that you depend upon. And then finally, making use of this reliable configuration, and then with the new JLink tool, is the ability to create custom images of the JDK. And this is particularly relevant in the world of the cloud of massive horizontal scalability, or in the small world of Internet Things where you have more of a resource constraints. Right now, you need like the entire JDK to run, all of rt.jar, which is like 80 some odd megabytes in Java 8, but yet all of our applications typically only make use of a very small portion of that, of the JDK. With the custom configure or the linking tool, you'll read in just what modules you're actually dependent upon, and then cut out from the JDK anything that you're not using, which should have significant savings in the images that you're creating. And I said, if you're running a couple of instances, this won't be much of a benefit, but if you're doing a lot of massive horizontal scalability, this could be very beneficial. Or if you're on a resource-constrained platform, this could also be beneficial. Maybe you can get like a slightly smaller SSD that could have a real savings in the device your company may be building. All right, so everything in Jigsaw is a module, and there's 3 different kinds of modules to help with migration. First is the unnamed module. So class path will still be around, and when you put jars on a class path, they automatically become unnamed modules. So unnamed modules, they export all their packages. They also require all modules, and they cannot be declared as a dependency. After that, we have automatic modules, and automatic modules is when a jar is placed onto the new module path. And so by default, the name of a automated jar is derived from the jar name. There's a lot of controversy around this from the Maven Central folks, and eventually they added a new optional automatic module name property to the main manifest in the jar, in which you can give a more stable name to that jar, or to that module. Like unnamed modules, they also export all their packages. They also require all modules, but they can be declared as a dependency. Then finally, we have explicit or named modules, and you define the characteristics of explicit or named modules in the new module info.java, and they can also be declared as a dependency, just like automatic modules. As I mentioned, switching to modularity is an extensive process. So here's obviously an extremely simple project and what the current file structure would look like. We just have our source file folder, and then we have conf.foo.bar as a package, which is also a folder, and then so on. So here's a modularized file structure. So we had added an additional com.foo.bar folder. We added our module info.jar, and then we have the rest of the file structure. Again, this is an extremely simple example, so sorry, you're fine. Yeah, this is an extremely simple example, but if you're talking about much larger applications, especially if you're working with a monolith, and in a monolith you may be modularizing multiple parts, it would be take a lot of time to make this change, and there'll also be a lot of risk involved. So again, you don't have to modularize, do some serious ROI calculations before attempting it, but it's there, and it is recommended for newer applications to consider modularizing it from the very beginning. All right, so I've been talking all about this exporting and requiring of modules and all this stuff. So this is kind of what I'm talking about. This is the new module info.java. A quick note, so there's several new reserved words. Most of them are the ones that are highlighted in blue. There's a couple of additional ones I'll cover. These are only reserved within module info.java. So if you have like a variable named module somewhere in your code or exports or whatever, you won't be running into any compilation issues unless for some reason you have another class named module info for some reason. All right, so let's just dissect this module info and kind of go through it line by line. At the very top, we have the modular declaration. And this defines the name of the module. An additional modifier for this could be open, as in open module com.foo.bar. And this will export all the packages within that module and then allows for deep reflective access into them. Currently, like the recommended practices when it comes to naming modules is to name it the lowest common package name for the module you're exporting, and you should be using the reverse DNS package structure naming. This helps ensures uniqueness, and it's just consistent. It's going to be much more familiar than trying to say this is the something module. This is like the services module instead. So next down we have the exports declarations, and this defines like a module's public API. So a note is each package must be exported individually. There is no wildcard. You can't just do com.foo.bar.star and then export all the sub-packages under com.foo.bar. And this is that was done on purpose just to make sure people think about what they're actually exporting and that they're not accidentally just adding new stuff to the public API when they weren't expecting to. Additional modifiers, you could do opens, and that would be in lieu of exports, as in like opens com.foo.service, com.foo.bar.service. You can also add to the end of it to do like opens com.foo.bar.model to or .hibernate, and that only gives the hibernate module access, deep reflective access into the package. No other modules will have that, so that's just there as like a security kind of thing. Next we have the provides, and this declares the services this module supports and the implementation it supports with. So this module supports the foo service interface, and then it supports it with the com.foo.bar service implementation. And then below that we have the uses, and this is declaring a service this module depends upon. So if you're familiar with Salad, this is a way of much more strictly enforcing the open-close, list cost substitution, and dependency abstraction principles. So below, this module depends upon org evil, and it presumably would have like an evil service impl. However, as long as org evil is not, again, exporting their service impl or the package that contains evil service impl, I can't have any bad coupling within com.foo.bar to evil service impl, as I simply will not have access to it at all. You can look up these services using the service locator class within Java. Finally, we have the requires, and this is the modules this module depends upon. Additional modifiers are transitive, and this is a way, so if like another module that depends upon com.foo.bar was to want to make use of a class within org.evil, if you require transitively within the com.foo.bar module, that client module won't also have to declare org.evil as a declaration as well. It gets it transitively just by pulling in or dependent upon com.foo.bar. Finally, and the last note is, as I mentioned, the entire JDK itself has been modularized, and java.base is one of those modules, and it's being implicitly required by all modules because that makes up the core elements of the Java framework, like integer, string, object, and so on. All right, so Spring support for Jigsaw. There is no real support with Spring and Spring 4.x for Jigsaw. But as you saw, I was able to run all these that microservice application, and I was using Spring 4.x. So I generally haven't had many issues running Spring 4.x applications in Java 9. You just have to run it all as undeclared modules. Once I tried to start doing like automatic modules, I ran into issues, though that was mostly in Hibernate. So you shouldn't at least have much issue sticking with Spring 4 in Java 9. Next, so Spring 5, which should be released here next month, it is supposed to be offering support for automatic modules, last time I heard. And then finally, Spring 6X, which is scheduled for 2019 or later, it should offer full Jigsaw support. And again, that's all kind of still very tentative, particularly for Spring 6X. All right. So particularly for people who might have been kind of loosely following Java 9, I just want to give a quick current state of Jigsaw. You might have heard back in May 8th, Jigsaw failed its initial public vote. There's like an executive committee of about 23 members, and each item must get 2/3 of the vote to be able to be accepted. And it failed its vote by 10 yes to 13 no, so things look pretty dire. There was then some meetings among the experts groups that kind of happened mid-May, and they recently released their minutes though, and actually those meetings went very well. One of the very loud no votes was from IBM, and recently the person representing IBM published a blog in which talking about how those meetings went well, so things are looking pretty positive, so it's likely that Java or Jigsaw will be approved for a mid-June release. The outcome of that vote, however, might impact the release date still. Members of the voting committee can have like yes, but with like strings attached, like yes, but you have to make these changes, and depending upon whether or not that's accepted, those changes could push out the release date. And of course, also, for some reason, Jigsaw is actually denied again, that could also push back the release date. So that July 27th release date, don't stake too much on it. It might get pushed back a few weeks also because there is supposedly no business pressure behind actually making that date. Finally, as I mentioned earlier, by default, the Jigsaw encapsulation, like all that exporting, so like the modules within the JDK itself are set up like that module info I just showed you, but you can disable that encapsulation. That's going to be by default, and there's going to be different kind of levels of like warnings you might get for that. But that's just also, again, make it easier to migrate to Java 9. All right, one quick second. So, with all of that out of the way, let's move on to some of the other new features coming in Java 9. One of my favorite is JShell. So JShell is a command line shell, and it's Java's implementation of a REPL. A REPL, if you aren't familiar with it, is a read, evaluate, print loop. And so REPLs are used as a way to like rapidly prototype with the languages, as it's just reading in like single commands and then evaluating them. So they're very helpful for just exploring APIs, or as a tool for teaching, which is the two reasons why JShell was part of Java 9. I will primarily focus on the second one for this. I know this might seem a little bit odd when speaking to a room full of experienced Java developers, but I do think it's actually kind of important. We're all Java developers, and we probably also want to remain Java developers. And one of the most important things for that to happen is the Java ecosystem must continue to thrive. And for it to thrive, we need new Java developers. And so schools and universities and high schools, we're starting to use like JavaScript and other languages that do have REPLs to introduce students to Java or to programming. And so if you learn JavaScript, as your first programming language, you're going to be more likely to continue on using it. So we need JShell to kind of help keep Java competitive with new developers. So here is your very basic Hello World program. To us, this seems trivial, but to a new developer, this could be quite daunting. I mean, what does public mean? What's a class? What's static doing? What's void? What's a system? What's a semicolon doing here? What's these brackets doing? And an instructor overwhelmed by all these questions might just say, don't worry, we'll get to all this later. But it raises the problem of how do you introduce these concepts in an individual fashion so that you're not overwhelming students with that. So let's actually take a look at JShell in action. All right. Is that large enough for everybody? Or okay, great. So to start up JShell, you just simply type JShell into your command line. Obviously, you have to be using Java 9 for this. And that boots it up. So just a quick tutorial on JShell. To actually talk to JShell itself, instead of it trying to evaluate whatever you're typing in as a Java expression, you just have to do \, and we can do like \help. And that gives us all the other different commands you can send to JShell. And for example, exit would have you leave JShell. All right, so let's just try implementing hello world in JShell. So we can just simply do system out.println hello world. And there we go, we have hello world. So now students just get this immediate feedback of actually programming. In JShell, when you have a single line command, you don't have to end it with a semicolon. JShell just simply assumes that, so that's just that much easier. So if hello world is the first program students write, typically the second one is like hello and then like appending some sort of user input to that. So let's implement that. So we'll just do void print hello. And so at this point, like an instructor could be introducing concepts of void and methods. So we're just kind of slowly building up different things. And we'll just do arg and system.out.print. We'll just add arg to the end of that. And so I do have to add a semicolon to the end of this because it's a multi-line command. It's doing methods, so we have to follow the full Java syntax at that point. All right, so we have this new method, print hello. And so JShell also offers tab completion. So print hello was the only one that had similarity to like what I typed in initially of PRI, but there was other options available. So if I just did like S, this showed all the different classes available. So let's just do, whoops, not sprint, but print hello, and just do and we get hello Spring Day Chicago. So hello world's the first, hello taking some sort of user input's the second. Another early practice is kind of then working with the different primitive types. So let's kind of look at that a little bit. So let's just do int x and then double y. So x is 0 because it's just an integer, and then y is 0.0 because it's floating points. And then we can just kind of look at like x equals 5 divided by 2, which will be 2, of course, because it's not doing any floating point math. Y equals 5 divided by 2 is 2.0. However, we did y equals 5.0 divided by 2, we get 2.5. But if we try this then with x, we get a lossy error. And again, this is very simple, nothing you guys didn't already know. But I just remember just learning about all these different things in school. Like the issues we were running into isn't, trying to learn this stuff. It was like forgetting semicolons, just forgetting brackets, having to just deal with like the basic syntax of the Java language. When you have like a room full of 20, 30 students, a student is having 1 or 2 issues every time or every day, multiply that by, you get up to 40 issues. And so an instructor is spending half their time just dealing with like syntax issues and compilation issues instead of actually teaching about the Java language. So that's just a quick tutorial into JShell. All right, so collection factory methods. So this is, I think, particularly helpful when doing unit testing. There's the arrays constructors, which really kind of do a lot of this stuff anyways, but still, like, even like a method that you want to test and it's taking in some sort of list, be it maps or lists, it's a very labor-intensive process just to create a new list. You have to do list string and then new array list and then list.add, a lot of typing. So these new factory methods, list of, were added. So you still have to do a list string, but then you can just simply do your items of like hello world or goodbye world. And it's not just strings, you can do any type of objects or any type of objects. Similar things were added to maps as well. You can just do map of entries and then add map.entry and then declare that. There's also an even shorter hand version for this, so I forgot to put this in the demo. Though when using that, just note that you can only do that up to 10 items. All right, so streams updates. Do not cross the streams though. So one issue with streams in Java 8 is they didn't handle working with infinite streams well. And so a change to that is doing the take while. So this stream will take a list or take its items until it fails a predicate, in this case an empty string. And so like the output from this would just be these closely concatenated together names of different Chicago sports teams. Similarly, you have drop while, and this will drop items from the list until a predicate is met, and then do whatever you want with that string. That's coming in Java 9. Private interface methods. So default and static methods were added to interfaces in Java 8. And then one issue came is that you would have multiple default or static methods, and then they may be having very similar code. Private methods are there now, so where you can just take that similar code, put it into a common private method, and just have that instead of copying and pasting. Try with resources. Updates. So try with resources added as part of Java 7. Before, at the declaration of the try, you would also have to declare the resource within that try. Now, as long as a resource is effectively final, you can declare it before. So here, a private or a local variable that's effectively final, we can just pass that in as try to the try, and then it can do the auto close on it. Or if we declare it final within as a class member, it can also be used the same way. Multi-release jars. So we saw some of these cool new features that were added in Java 9, like for example streams. And so let's say a library that's written right now in Java 8 is making use of a stream, but it also wants to better handle infinite streams. Maybe it solves that with Java 8, but it sees this cool new feature in Java 9 and wants to make use of that. So multi-release jars are being added. So within the meta-inf directory of a jar, and then adding the multi-releases true property to the manifest, and then adding a versions folder, and then the number for that version that's related to. So if Java 8 works with this, it just ignores all this stuff because it doesn't recognize it. But for example, with Java 9, if it was to load this jar, instead of taking on the main foo and bar classes, it would actually use the foo and bar class that's under 9. If a Java 10 class, or JVM, was to read this, it would take in the foo class from 9 and then the bar class from 10. So this is just a way for particularly like library developers to be able to make early use of new features, but not then have to wait for or force compatibility for all their clients. Because like right now, Java or Spring 4 is written in or Java 1.6. Spring 5 will be in 8. So but if like Spring 6 is written in 9 and there's a new feature in 10, it can take advantage of that without having to have all of its users be using Java 10. We have finally made it to the most important part of this presentation, and that's documentation. Of course, everybody here meticulously documents their public API, right? So the Java Doc enhancements, Java Doc is now searchable. It's also being produced in HTML5 compliant HTML. For deprecation enhancements, there's 2 new methods that were added, for removal, which is a Boolean, and also since, which is just a random or a arbitrary string. So you can do since like a version number or since a date. We can just take a quick look at what that looks like. So this is a Java doc for one of the applications I showed you guys earlier. And so as you can see, we can just type in employee or into the search box and we get a list. And then here we have the deprecation enhancements that employee repository is normally removed, and this was declared since the 22nd of this month. All right, so just a few more additional changes. A really big one that I didn't have any time to get to is there's a lot of reactive updates. Jarvis and Mark are about to give a fantastic presentation on reactive. I just didn't have time to get to this. G1, there's a new default garbage collector, or it's going to become the new default garbage collector for Java 9. It was introduced in 8. One really nice feature of that, I don't know if it's necessarily to Java 9, but or if it's available to Java 8 as well, is that if there's multiple versions of the same string, so like if you have 2 strings called hello world, it will just use the same memory reference for those. So that's very beneficial because some of the analysis done by Java architects was that like a lot of the memory that's being taken up is just with strings, and there's a lot of duplicate strings out there. Also, strings are becoming more compact. They'll be backed by a byte array instead of a char array for certain cases, but it won't change any of the API. New version format, so no longer is it going to be like 1.8_u whatever. It will be actually 9, like just the very standard version numbering with the final version part of it, so like 9.1, like 0.0. That final portion is actually the security version of it, and that won't change with like every minor update. So if you have like 2 versions, like 9.0.25 and 9.1.10, 9.0.25 has more recent security updates than 9.1.10. So just kind of note that. HTTP 2 support. This is experimental. This will within like the JDK. This is like in a different like module that's called experimental. If you want to make use of it, I would definitely recommend if there's like maybe some library or some level of abstraction between it and your code, because with it being experimental, they're just saying this public API could change at some point or some later major version. Unified garbage collection logging, unified JVM logging, and then also a new stack walking API. Some removals. The JHat command line tool is being removed. Applets, God help you if you're still using applets. You're still using applets, and now you're kind of going away in Java 9. Internal APIs, this is a result of Jigsaw that, for example, com.sun.unsafe is no longer going to be publicly available. Again, that can be turned off with the command line flags, but just kind of know that in future releases, those command line flags are going to be scaled back or taken away altogether. So start changing your code if you're making use of it. I doubt many people here are directly making use of it, but they may be through libraries. Some deprecated garbage collection combinations. I actually kind of ran into this a little bit. I was trying to run a Kafka application, and just at least within its startup script, it was using an incorrect garbage collection combination. The hprof agent is also being removed. And again, just because there's better uses or better alternatives. Developer tools. All right, so if you're using IntelliJ, they have already released public or production support for JDK 9. Obviously, JDK 9 is not released, and it's changing a bit, so they're probably going to have some more releases post Java 9 release, and they're definitely looking for a lot of feedback. Eclipse, you have to be on Oxygen, and it's currently in beta. It's also a work in progress. That means that's available in their nightly builds. As I mentioned, Maven 3.0 is compatible with Java 9. And supposedly, again, Gradle 3.0 is also compatible with Java 9. But as I mentioned, there's still some issues with that. So if you kind of want to keep up with Java 9 news, I found these three people very great resources to follow. Paul Baker and Sandra Mock, they're mostly on the Jigsaw side. Nikolai Parlog, he's a good general Java 9 resource as well. Here's some great talks. Trista G, she just gave a talk. It actually kind of stole a little bit from her talk from my presentation on real-world Java 9, in which she also kind of gets into like the reactive updates. Mark Reinhold, also at that same conference, kind of gave some updates on the current state of Java 9. The Java 9 modularity in action, that's, like I mentioned, that's about a 2-hour talk. It's back from November. Some changes have been made to Jigsaw since then, but it's still very relevant, and it still gives at least the overall concept of what Jigsaw is. And then here's a couple more. And then finally, get started. Here are the links to the early access builds of the Java 9, and just maybe just try playing around with it. So, all right, that's all I have time for. Am I over time? Okay. Thank you.